let's just start off our session. Hello, welcome. This is the Inner Workings Room, and my name is Stefano, and I'm going to be your host for today's panel. And I am very excited to have you here. Before we begin, I would like to begin by gratefully acknowledging that Science World is located on the traditional and unceded Musqueam, Squamish, and Tsleil-Waututh village site of Sanok. Now, we're going to start today with a quick introduction from our amazing group of mentors, followed by a hosted discussion by me, your host. If you have any questions for the mentors, please feel free to put those in the chat at any time. I will also be your technician, and I will be monitoring the chat. So if you have any tech issues, I'd be more than happy to assist. And I do ask that you keep comments in the chat and any questions respectful and relevant to the topics being discussed. All right, it's time to meet our mentors. Let's bring them up into the stream. Here we are. I'm going to bring in Sarah Bowers. Bring in ML Islamzada. Oops, there she is. And of course, also Victoria Peters. Welcome. Let's take a moment to introduce ourselves to our viewers. 5 viewers, welcome all of you. And if you have any questions, please do put them in the chat. Now is a good time while we get to meet our mentors. Sarah, why don't you tell us a little bit about yourself?
Yeah, hi everyone. Thanks for joining. I'm Sarah. I'm a scientist in training. So that means I'm a PhD student and I'm studying immunology. So immunology is about our immune system, and our immune system is what stops us, normally would protect us from germs and things and stops us from getting sick. And I study what goes wrong particularly in children when they do get sick and their immune systems aren't working the way they should. I work at BC Children's Hospital, which is quite close to Science World. I think it's just up the road. And yeah, I think one of my favorite things about my job is that I get to go into work each day and do experiments. So if any of you guys have any questions about what goes into planning experiments, I'd be happy to answer any of those.
Wonderful. I'm actually going to just say hello. We've got Allison says hello. Melly says hello. Arlene says hello. And we say hello back. Let's move on to Emel and get Emel to tell us a little bit about herself.
Hello, folks. I also work in Vancouver. I work in Center for Blood Research in a multi-scale design lab. So what we do in the lab is we build things. And we build things in particular to check when a person is sick, if we can catch that the fact that they're sick, or if we're doing any kind of treatment, can we actually figure out whether the treatment is working or not? My job in particular is to work with blood. I check to make sure that the blood is adequate quality, that it works well for transfusions, and that's what I do. And that's what actually is one of the coolest things about my job. I go to work every day, I build things, and I work with blood.
All right, so immunology, some blood. Let's get to know Victoria a little bit in our first part of our session. Victoria?
All right, so I work at the Canadian Food Inspection Agency in Ottawa, and I was originally hired to work in the COVID-19 diagnostic lab, and then recently I was transferred into the rabies lab. So now I get to do brain surgeries every day and open up brains from animal heads and look for different parts of the brains, make microscope slides, and then test to see if animals have rabies.
That is 3 introductions that are super amazing. I hope it raises some questions with our viewers right now. Welcome, viewers. I see some of you have said hello in the chat. Please feel free to keep saying hello, and feel free to start asking questions of our panelists, and they'll happily answer those questions in the time we have together. If there's something that they said that sparked some curiosity, that's what we want to investigate a little further. Is there anything each of you would like to ask of each other or mention about with each other? Have you worked together? Any of you worked together before?
So Emel and I haven't worked together before, but we actually work under the same umbrella of the Center for Blood Research. So that means that both of us do experiments and things that are related to blood and testing things in blood and making sure that blood's of good enough quality to do experiments on.
Cool. Emel, if I can ask, how did you get started in this, given that Sarah is sort of early career and it sounds like you're getting nicely established? Maybe a good tip to share among our panelists and also with our viewers.
I got started by being very, very curious about disease in general. I always wondered how do things go wrong in a body and what we can do about it. So when I started university, I was just looking for any opportunities to study it more. And there are multiple ways you can actually go to work in a lab hands-on. So I started back in my undergrad. And I worked a little bit in a pharmaceutical company, a little bit in an actual research lab. And I realized I really love research. It's challenging, but it's also really rewarding where you find something else that can help a lot of people. So I found a master's program and then a PhD program and stayed on.
Very cool. Now, Victoria, you started in one area and then you moved to another. Can you tell us a little bit about sort of that transition?
Yeah, so I started working in the COVID lab in Ottawa, and the way this lab was designed is that the lab worked as doing COVID tests when certain provinces were overwhelmed with their tests. So I don't know if you guys remember, Newfoundland was hit really hard back in February. So then we would take some of Newfoundland's tests and we would complete them for them. And then different provinces, when they were overwhelmed, we would just take over their tests for them. Eventually, provinces were able to kind of get their testing under control, so they didn't need us so much anymore. So at that point, they found us new labs to go in, and the rabies lab had an opening, so that's how I ended up in there.
It sounds like you're really excited about that rabies lab switch.
Some days.
Yeah. Can I ask each of you, maybe I'll go through one at a time as our viewers maybe think of some questions on their own, or if they're just enjoying listening to you, and that's totally great. But if they do have questions, please, in the chat. I will ask if you all have an advice you would give a 12-year-old who is interested in each of your lines of work or just broadly in the sector. Let's start with Sarah.
Yeah, I would say, I think, well, two things. One is if you get really excited about something in your school classes, like in your general science school classes or coming to discussions like these, try to find people that you can reach out to and talk to about them, because you can like build on what you're learning and get excited about it before you go off to further education or find a job. So find something that you get excited about, and then the second thing would be to find people that you can talk to about that and get more information. So those would be my two pieces of advice.
People to talk to like yourself.
Yeah.
In this kind of a session. Wonderful.
Yeah,
so that's a cue to you. If you have any questions for Sarah, pop them in the chat. Let's hear from Victoria next. Something you would say to a 12-year-old potentially curious about this kind of job.
Okay, this one might be a tad bit controversial. Also, it kind of applies to a little bit of an older demographic, but the one thing I would strongly encourage everyone to do if they're interested in science is to consider the college route rather than the university route, because especially in government jobs where I am in now, that you can have the same job when you've done a 2-year college program versus doing a 6-year university program like I did. So a lot of people that I've worked with, we've had discussions about this, where when you get to university, a lot of times teachers will persuade you to explore more university programs, but I highly recommend keeping your options open and exploring college programs as well, because they could be super, super beneficial, and you can get to your career a lot faster if you go the college route, and it's usually cheaper.
Interesting. So it sounds to me what you're just saying is researching what you want to do before you go into research.
Sure. Don't like blow away the idea of college. A lot of guidance counselors and teachers will say, oh, if you have the grades, check out university. But I also think college is a really, really great option, and it gets overlooked by a lot of people because it kind of gets looked down upon by, teachers when you get to high school. So whenever you get there, definitely consider looking into college rather than just university.
Ariane here asks what the difference is between a college and a university. Maybe you can answer that in the chat for us while I go over to ML for the same question.
Yeah, actually building on what Sarah and Victoria both said, I would advise people to be curious. And if you're interested in any kind of topic, just really research it. Learn about it outside of school, maybe Google it, maybe, as Sarah suggested, talk to different mentors. And as Victoria suggested, search on how you can actually achieve a goal of studying or learning more about something. And one more thing I would really suggest, if you find a group of people who are interested in the same thing, it's always more fun to do it together in a group. So do find people who have the same kind of interest as you, some kind of passions with you. And then you can actually divide the work on figuring out how to get there. And do it together, and it's always more fun to do it in a group.
Very cool, like we're doing right now, talking in a group.
Yeah.
Can I just, I'll open up to whoever wants to answer first, maybe pop your hand up so that we don't interrupt each other, to our great panelists here. What is something about your industry that surprised you when you started? Maybe something you had went in with a preconceived notion about what you were going to get into, and something that maybe surprised you for the good or for the hard or for the challenging potentially as well.
There is a lot of group work in research. You don't necessarily expect it going in, but there's a lot of group work, there's a lot of talking, there's a lot of interactions, there's even a little bit of politics, and it's not a bad thing at all. But sometimes in high school we complain saying, oh, why am I doing all of this group projects? It's boring, it's unnecessary. But no, it's very necessary. When you do get to a professional career, you work with people, and it's always good to have this kind of practice to be able to work with different kinds of people towards a common goal. So when you come to a more professional setting, you're kind of prepared for this kind of work.
Awesome. It sounds like it's not just solo work in a lab by yourself. It really is collaborating and learning together and working together from studying through to the actual job itself. Sarah or Victoria, would you like to jump in on that?
I have one thing I want to butt in about. I want to respond to Arlene, but I'm not able to comment in the chat at all.
Why don't you just tell her, right, directly?
Oh, okay, sure. So Arlene, the difference between college and university, this is going to be a very broad explanation. College is normally to train you for one specific career. Say you're like, oh, I really like biotechnology. So I don't know, lab work. You're going to go to a program. They're usually 2 to 3 years at college, and you're going to take courses on biotechnology. If you go to university, that's usually 4 years, and you can do something called like a bachelor's of science, and you'll have a broad education of a variety of subjects. So college is more streamlined towards teaching you to perform like one certain career, and then university is more broad normally. So you learn a more wider variety of subjects. I don't know if anyone wants to chime in more on that, but that's how I'd probably describe the difference between college and university.
I saw a lot of nodding heads in there. Sarah, did you want to jump back onto the conversation we were having earlier? You had something to say?
Oh, yeah. I was just going to say, so thanks, Victoria. And I was just going to say about something that surprised me about my industry, or I guess like getting into immunology research in particular, is I think how much we don't know yet. So you read textbooks and everything's written out and you can see nice diagrams and it shows how everything works. But I think one thing that really surprised me is how much we don't know, and also how much, even people, like how many open questions there still are. So that's something that's really exciting and something I didn't know, didn't appreciate.
Fair enough. Ariane thanks you and says, I've learned something now. That's a wonderful situation to be in here in this session. Speaking of learning, I'm wondering if there's anything you've learned that's recently in the actual field, not when you were studying for it, but something you've learned recently that is just exciting and you want to share from your work situation and what you do every day. Who would like to go first? Let's see. You got to think about the answers here. Give you time to think before you offer that. It can also just be a favorite thing that you get to do in your day-to-day work.
Okay, I can go along with my favorite thing to do. Sure. So in the rabies lab, every morning we saw open the heads of different animals. So we have a whole bunch of different animals we'll get cows, cats, dogs, mice, bats, a whole bunch of different types of animals. And it's this is super morbid, but it's kind of really fun to perform the brain surgeries. We have our little tools and we're looking for the different parts of the brain. So it's like I can pretend to be a brain surgeon without having to go to school for 15 years. So it's just really fun to get to see, like the different brain structures of every animal. Every animal's brain looks totally different. And it's so cool to see like different parts of their brain that don't look normal. So then you're like, oh, that's why the animal was sent for rabies testing, because their brain was all messed up. So it's just kind of fun to do brain surgeries every day. And then I don't have to do a perfect job because they're not humans. So it's fun to mingle it.
Right on. That's very exciting and cool. Amel, do you think you could share something that we don't know about blood, and something that maybe is a preconceived notion that maybe you can debunk for us?
Sure. One of the things, I can talk a little about red blood cells, because that's the cells that I work with in particular. So not a lot of people know that, but red blood cells are actually the ballerinas of the cell world. They're very, very flexible, and they actually can deform and go through openings that are much, much smaller than their own size. And some diseases like thalassemia arise when cells actually lose their proper shape and can't squeeze and grow through openings like they're supposed to. And that's part of what we study in our lab.
Wow, that's very cool. I'm just putting that in the chat. I'll just make sure I type it correctly. And you said that red blood cells are the ballerinas of the cell world. Is that right? What a lovely image. Sarah, your turn to give us some fun imagery. I think Victoria's given us some very, very clear descriptions and some artistic analogies from Mel. Sarah, what do you got for us?
Yeah, no, I'm not sure of anything as good as the ballerinas, but yeah, I guess one thing that's really interesting that we just found in our lab was there's a particular thing that we can see in the blood. So it's called an enzyme, or a protein that's an enzyme, and it normally makes a certain product. So it will produce something. And we recently found that this enzyme, or this protein, doesn't make a particular product, and that's something that we can use to actually diagnose a disease. So that was a really exciting finding that we recently had in our lab.
Very cool. I'm just answering some things on the chat here. Technology. Any questions from the chat? Now's your last chance. We're going to be wrapping it up a little bit soon, relatively soon here. I see that we've got 7 viewers. I want to thank you so much. And you can also share that this is going to be available on YouTube later and watch it afterwards and enjoy this little session. And enjoy the rest of your experience with Girls in STEAM. And let's see. We've got a few minutes left. What's burning in our panelists' minds that they want to make sure they communicate to our fantastic audience today and onward? Let's see. You can just do one of these if you want to speak first, because Emel, there you go. Go for it.
I think I just want to point out that the most important thing to be able to do is not to be afraid when you fail. That's something that I learned when I started doing research, and I wish I've learned sooner. Sometimes you do one thing over and over and over, and it doesn't work 100 times, but it does work on 101st. So one thing I would say is to stay encouraged. And the second thing I would say is when you do fail, that's okay. Try to see what you've done and maybe think what you could have done differently. And then just try again and try it again. It's okay to change your mind and move away from something, but it's also okay to be very persistent and try it over and over and over to make sure it works the way you want it to work. And that's a big part of research. It's 99% failure and only around 1% of success. But that success is very satisfying.
That's a very, very great way to frame it. I also find here at Science World that we like to say, I don't know, as one of the answers. And then that encourages us to find that answer. Because if you have the answer, that's great. But sometimes knowing what's not the answer also gives us a lot of information. That's
For
great.
sure.
Thanks, Mel. That was really great. Sarah or Victoria? Sarah, go. Let me know what's something cool you want to make sure that these fine folks listening are going to learn today.
Yeah, well, I was definitely second what Mel said, and I think not thinking of things as mistakes, but thinking of them as potentially learning opportunities. So you think back on what you did and what you could do differently next time and make a change. I think what I really also like to communicate if people are interested in getting into like a lab job where you're doing science experiments every day is to get practice doing things with your hands. So even things like cooking, that's like practicing doing science experiments at home. So reshaping things that you would do in your day-to-day life and thinking of them as science experiments, I think that's fun. So that's one of the reasons why I really love to cook, is because it's like I get to do science experiments at home.
That's awesome. Cool. Victoria?
I'm fresh out of ideas.
You know what? And that's okay. I feel like that sometimes that we are put on the spot sometimes and we don't always have all the right answers. Just like as we've discovered, persistence and thinking about stuff further. I would really like to thank all 3 of you and all our viewers for joining us today. And for sharing your experiences with us. I'm going to be ending this broadcast here, and you can head on back to the mainstream in our lobby for your next activity. To my viewers, and thank you so much. If you can, even though they can't hear you, actually, let's in the audience just give them a big round of applause to our mentors for joining us today. And please feel free to give them a wave and say see you later. We hope to get to I hope that you all get to cross paths one day in your areas of interests and share experiences together. Thank you so much to our mentors for being here today, and thank you so much on our behalf to all of you joining us. Have a great day.
Thank you for joining, everyone.
Bye now.